If you get into a scenario where there's water involved or it's raining out and there's electricity around the facility, you potentially have an electrical shock scenario where the FRP material is all non-conductive, meaning you could take a blast of lightning and you're not going to get killed. Versus if you were on a steel platform, for example, when you took a shot of lightning, the odds are you're going to get seriously injured.
Hello and welcome to the Pumps and Systems podcast. I am your host, Tom Bear, a managing editor at Pumps and Systems magazine. Today we're speaking with Tom Wright, Business Development Director at Bedford Reinforced Plastics. He's going to be speaking with us about fiberglass-reinforced polymer, or FRP, and its uses in the water and wastewater industry. So without any further ado, let's get into the episode. Okay, so welcome to the Pumps and Systems podcast. We really appreciate you being here. So how are you doing today?
I'm doing very well. Thank you.
That is good to hear. Okay, so today we're going to be talking about fiberglass reinforced polymer in the water and wastewater industry. But before we get into that, could you introduce yourself? So tell us who you are, what you do, anything you'd like our listeners and viewers to know.
Okay, thank you very much. My name is Tom Wright, and I'm the Business Development Director here at Bedford Reinforced Plastics. So my role is I have a multi-role. Anything that's new or crazy or different or out of the ordinary generally comes across my desk. That's about it. We got a lot to talk about in this particular market, so I'm good to go.
Great. Okay, so then we'll get right into our main topic then. So I always like to start with just the absolute basics. So to start off, could you tell us what is fiberglass reinforced polymer, or FRP, and what applications is it used in for water and wastewater?
FRP, or fiberglass reinforced polymer, that's a great question. It's the materials that we use to manufacture the profiles. Okay. There is three basic raw materials that we use. There's resin, and both in polyester resins and vinyl ester resins for more corrosion resistant applications. And then there's the actual fiberglass itself, and there's what's called continuous filament or roving, which the pultrusions achieve their longitudinal properties using the roving. And then the third one is continuous filament mat, which basically are layers of mat that run in the transverse direction of the pultrusion. And so all three of those raw materials, make up the FRP, or make up, by using the pultrusion process, the shapes that are used in the water treatment arena.
Would you mind explaining just a little bit about what pultrusion means, if you don't mind?
Pultrusion it's a great question too. It's not in a dictionary. It's actually not a word.
Oh, okay.
It's the name of the process that we use, and it is basically pulling reinforcements such as the glass through a resin impregnation system, the resin, into a heated steel die, and the heat of the die reacts with the hardener that's mixed into the resin, and the die is made to the profile that you're trying to make. For example, if we're making a sludge channel flight, which we do, and it's 3 inches by 8 inch, basically a channel section, the pultrusion die is machined to that section. And then on the downstream end of the process, in our case, there's a caterpillar style puller, which basically has 2 tracks that grip the part, and it pulls everything through the heated die. It creates and cures to the finished part. So it pulls the C channel, in this case, through the puller. And then the last step is a cutoff saw, which, if we're making 20-foot sections for an order, if they're cut off at 20 foot, loaded onto a skid, and then it's a continuous process, meaning if you keep adding the raw materials in and nothing goes wrong, then you keep manufacturing material.
Okay, Thank you, because yeah, I had not heard of it, and I don't feel so bad now knowing that it is not like a dictionary type word. So,
Yeah, it's the name of the process.
so in the wastewater industry, when it comes to safety structures, we usually think of things like platforms or machine guarding. But what else falls into that category?
Well, the platforms are obviously huge. Stairway systems are also part of, particularly if the tank is elevated. Normally, the tanks are made out of concrete, poured concrete. So if they're up out of the ground or elevated from the ground, there needs to be a way. So there's stair systems that are used in combination with the platforms. There absolutely is handrail used all over the facility to keep somebody, obviously from falling into the tank. Another big one is depending on the size of the tank, there are bridges that are needed to be installed so that you can get out into the center of the tank or other equipment that's in the tank for maintenance and service and safety related issues. We also manufacture and sell quite a bit of FRP grading. There's grading used everywhere in the water treatment plants, meaning around the tanks, there are trenches that hold piping that move the water, and they're open trenches. So we sell the panels of grading that ends up making a walking surface or a floor or a floor system that you can safely walk over the open trenches. Those are the main shapes that are used. If you get into other on the custom side of our business, depending on who the OEM is and their particular system, there are custom profiles that are used down in the tank that hold media together and different fill products together. So it's there's a whole other realm of material that are used typically.
So then how does FRP compare to other safety structure options like metal, wood, aluminum, things like that?
I'm going to be somewhat biased here when I say because obviously we make it, so FRP to me is great. But in reality, let's talk about metal or meaning steel or uncoated steel or aluminum. The big thing about FRP or the pultruded shapes, they're a tenth the weight of steel and a third the weight of aluminum. So by design, they're easier to handle, easier to install than steel or aluminum. And if you get into a scenario where there's water involved or it's raining out and there's electricity around the facility, you potentially have an electrical shock scenario where the FRP material is all non-conductive, meaning you could take a blast of lightning and you're not going to get killed. Versus if you were on a steel platform, for example, and you took a shot of lightning, the odds are you're going to get seriously injured. Relative to wood, when I first started in the industry, 40 years ago, most of these products were made out of wood, either Douglas fir or redwood. And because of the quality of the wood and the availability of the woods, the FRP became the preferred choice for availability and cost reasons, but also on the corrosiveness or the rotting issue. A lot of the woods today, you can't use into water treatment because they simply won't last. They rot. And the quality of the lumber, when the forest growers today, they're growing lumber, they force grow it. So it's not as dense as what it used to be. So that it just doesn't last anywhere near like it did, 25 years ago.
Oh, that makes a lot of sense. So you already touched on this a little bit, but we know it's extremely important to practice electrical safety when you're working in a wet environment. So what advantages does FRP have in terms of things like that?
The big thing is, like I mentioned, is the fact that it is all of the FRP and the resin that's used in the process, it's all non-conductive. So you can, literally meaning if you're working at a facility and there's an electrical enclosure there and you're doing maintenance to it, they'll go through their safety protocols of lock out everything. But in the event that there was something that malfunctioned, the safety worker or the maintenance worker could still do his job and knowing fully well that he's going to be protected because the FRP is non-conductive. What that means in a nutshell is the electrical current won't pass through it, which means then you being the person on the other end, even though you're grounded, you're standing on the ground or the material, you're not going to receive the electrical shock.
And of course, we do not want that. That would be very
Right,
bad. So,
exactly. That would be a serious no.
one issue that is unique to the water industry is fiber bloom. Can you tell us what exactly is fiber bloom? And second, how does FRP mitigate that?
Fiber bloom, you mentioned the water market. Let's expand that a little bit and let's just say composites in general. It's an issue. It's our Achilles heel, actually. What it is, it's the UV attack from the sun, meaning if you go to the beach with your family and your kids during the summer, if you don't use the proper suntan lotion, your skin ends up getting sunburned. The FRP is the same way, or everything is the same way, meaning the UV rays of the sun essentially attacks whatever, and it penetrates into the substrate and generates heat, which in turn causes your skin, for example, to be sunburned. Or on the FRP side, it starts to break down the surface of the fiberglass, which means then ultimately it's going to expose the glass fibers. And when the glass fibers are exposed, the term UV degradation now is applied. So we do multiple things to help mitigate that. We put what's called a UV inhibitor into the mix. That's number one. And when the sun attacks it, the UV inhibitor tries to absorb the heat, as I just mentioned, with internal into the part. So that's number one, and it helps dissipate the heat away. Number two, we use a polyester veil around the outer perimeter of the profiles that we manufacture, and it's a 10 mil thick veil. So in the process, in the manufacturing process, this veil absorbs quite a bit of resin. So now you have a much thicker resin-rich surface to the pultruded parts, which is the number two way of slowing down the UV degradation or fiber blooming. And then the third one that we are now focusing heavily on is we actually shield the pultruded sections that radically reduces the fiber blooming or the UV degradation. Now, the negative with that is there's additional cost to that. You know what I mean? So not every application can absorb additional cost.
Let's talk a little more about FRP in terms of how it compares to other materials. So, what can you tell us about things like cost, longevity, things like that?
From the cost perspective, the pultruded shapes are petroleum based. So unfortunately, when oil goes up, the raw materials go up, our costing goes up. You know what I mean? So you can't lose sight of that. But as a general one-to-one comparison, uncoated plain steel, mild alloy steel, we are anywhere from 3 to 4 times the cost per pound. Now, bear in mind that we're a tenth the weight of mild steel. So it's a little confusing on how you calculate that. If you step up to coated steel, like epoxy coated steel, for example, the gap narrows quite a bit, meaning instead of 3 to 4 times, you're probably 1.5 to 2 times the cost per pound. If you talk stainless steel now, where you've narrowed the gap to basically where we're competitive or equal to basically stainless steel. So there's a rough kind of a outline of relative to the cost.
Okay. And in terms of longevity?
There's really no predator that we have to the composite. So the material pultrusion has been around since the early 50s. So it's been, out in service for, many, many, many years. And if the maintenance people of a facility, doesn't really matter what, but the water treatment plant or the sewage treatment plant, if they maintain the maintenance, meaning Keep things clean and don't let, other debris build up on a structure. And if you do start to see any degradation, if you can coat it or treat it. Or if you're doing maintenance, you don't want to drop like a heavy motor on it to damage it or gouge it. If you can control all those things, you're talking easily 25, 30 years, service life or more, depending on the application.
So, does FRP apply to new facilities and aging infrastructure too?
It does, yes. Where if you have the new facility, for example, that's the easiest, meaning generally the owner puts out a project bid, and they generally work with an engineering firm to put the spec package and the bid package together. And then the major OEMs in the US then obviously submits a bid, and then they start the process. So if it's kind of like a soup to nut thing, wherein you're breaking ground and you're going to end up having a final new unit, the FRP material is spec'd in, and in the proper sequence of the erection, if you will, the FRP products are installed. Conversely, on an existing facility, let's say there's units that are left over with wood or with steel components, and 10, 15, 20 years into their service, if they're doing maintenance inspections or safety inspections, and they start to see rust or corrosion or welded joints that are starting to be compromised, or even in aluminum can also corrode as well, depending if it's on the salt waters involved, let's say on a coastal application. You can easily The engineer can easily spec replacement of the FRP material, and it's simply then the contractor comes in. Another beauty of the FRP material is you do not need expensive welders to install steel or aluminum. You can use a general carpenter or general labor type. So you're ultimately saving, installation costs by upgrading facilities using the FRP.
The modular FRP structures are designed to address safety and access issues within the water industry, and also adjacent industries like processing, packaging, things like that. So, are there any other applications it's used for?
Well, really, I like to say the sky's the limit. I mean, not only in a sewage treatment or water treatment plant, there's literally, if you're moving from the ground level elevation up to, let's say, a silo or other tanks or other equipment that's within the system, FRP can be used to create a complete stair tower. Where you're familiar with a galvanized steel stair system where you walk up, literally you go up to the ceiling or the roof of the building. We can take that out and substitute a FRP stair tower. And ladders, for example, going up the side of tanks. Generally, if you're moving or climbing anything greater than about 6 foot, you need to have either a platform system with stairs. You need to have a ladder system. Again, because of OSHA, and there's certain requirements from the safety element, that all that wraps up to where the FRP platforms, ladders, railing, stair towers, bridges, all that takes care of all those issues at one fell swoop.
So, before we wrap things up, is there anything else you'd like to share or any final thoughts you'd like to leave us with?
The only other thing I guess I'd like to say is that we're also heavily not only into the water treatment on the sewage treatment side, we're now also very heavily involved in the water purification side, where we've developed and we're using an FRP baffle system that's used in the tanks where you get your drinking water, let's say from your city. Somewhere in that system, the city insists that good chemicals, let's be clear there, are injected into the water to make sure that the water is safe to drink. And these baffle wall systems are installed into these tanks, wherein if you imagine the water coming in at the entrance end of the tank, if you didn't have the baffle system, the stuff would never mix in and actually purify the water. So these baffle walls create like a maze, if you will, in these tanks that slows the flow of the water. So when they enter in the good chemicals, then there's enough time for them to be absorbed into the water to guarantee you're going to get the cleanest and safest drinking water. That's number one. And then number two, back to this on the sewage side of the market, there's wastewater treatment plants in every city. And they used to be, on the outskirts of the city. Well, now, since the city's expanding, homes are being constructed, much closer to these sewage treatment facilities. So people are complaining, as you can well imagine, of the odor. So now here in the US, there's OEMs that are offering and have designed what they call odor control systems. So in our case, we manufacture what they call tank covers or odor control covers, that these systems can be installed on the tanks now, and they're actually pressurized so that the community doesn't get the odor, but yet it's still, the system still works and does its thing. So ultimately everything is cleaned up, and then water can be discharged, either to be reused or safely discharged in a creek or a river. So those are probably the two biggest market areas for growth in the water treatment market.
Yeah, it seems like a very wide variety of different applications there.
Yes, definitely.
Okay, so then I will say thank you so much for being here and talking with us. We really appreciate it.
Very good. I appreciate it too. Have a good day.
Huge thanks to Tom Wright for taking the time to speak with us today about fiberglass-reinforced polymer. If you're listening to the podcast and would like to watch it, head over to our YouTube channel to watch the full video version. That's going to do it for this episode. Thank you so much for listening or watching, and we will see you next time.